So apparently, the heat death of the universe would happen before my password gets cracked. It would take 100 quadrillion years with 25 characters here. So Mr. Holsey is super coolio, dude. Is just the best password ever because it's super long. Okay, right? So let me show you how a cracking algorithm might kind of look. Let's assume that instead of having a really good password with 25 letters, let's assume that I only have two. So in this method, or excuse me, this function, test password, I just said pass because I don't really have anything to test it with. I don't have a database of passwords and usernames and stuff. And also, I created this list of lowercase letters. So I'm assuming that this password only has two lowercase letters. I know there are better ways to create this, but I wanted to list them out here for you. So basically, it goes through for each letter in lowercase, and I had to name it letter 1 because I'm doing it again down here, letter 2. So for each letter in lowercase, it checks all of these. It goes through all of these. So let's just look at the first one, A. So So when letter 1 is A, then it does this. So let's assume the letter 1 is A. Then it looks at all letters in lowercase, so all of them again, regardless of what they are. So let's assume that this is A as well. So then A, and then we do join on it. So it joins these two in this list that I made, joins these two letters in this list that I made into a string. So AA is the string. So then it tests password using AA. Oh, this got to be, password to check. Password, something like that. So AA. So then it goes to the next letter, B. So then it's AB. Then it's AC. Then it's AD. And then it gets through all the way through AZ. Then it goes through BA, BB, BC, all the way. So you can see that when I start scaling this up, if I went into for letter 3 in lowercase, first of all, it'd be hard to write. There's got to be a better way to write that. Oops. And then second of all, you can see this is just going to take forever and ever and ever because I'm doing the same algorithm that I had times another 26. Now imagine if there were lowercase and uppercase letters. That'd be 52. So I'm doing the same number of checks that I had before times 52 for each new character that I add to it. So it's going to scale up exponentially by number of characters. Okay, so this is a password cracking algorithm. It's called the brute force method. The brute force method is just not going to be solved in reasonable time. It's not going to happen in reasonable time. The heat death of the universe will occur before this password is cracked. All right. So other scenarios, you will find problems where there's just no good algorithm for it. You've got to kind of make some assumptions. So what kind of assumptions would you make when cracking my password? Well, maybe you could say that Mr. Holsey is a bit of a narcissist, so he's definitely going to have Holsey in his name somewhere. Okay, so that will cut down a lot on the number of checks that you'll have to make. Maybe you know that Mr. Holsey's favorite word is Qleo with a K-E-W, although it's not. Please don't quote me on that. Maybe you know that, and so you know that word has to be in there. Maybe you know that you have to have consecutive words and not just garble, so you can cut down a lot of the checks that way. So those kinds of rules of thumb are called heuristics. Different from algorithms, they can be used in conjunction with algorithms, but a heuristic is like a rule of thumb. Algorithm is a step-by-step process. Think of this example. If I want to tell somebody how to make a peanut butter and jelly sandwich, all I got to tell them is the steps. That's an algorithm. So I say, go to the pantry, grab the peanut butter, all the detailed steps. I can make my algorithm more or less detailed, more or less complex, with more or less repetition, more or less branching, selection, right, with if statements and stuff. But it's going to be a step-by-step process that happens exactly the same way each time. Binary search, linear search, those are algorithms. A heuristic is a rule of thumb, or I like to say some advice. So if someone were to come up to me and tell me, hey, Mr. Olsey, can you give me an algorithm for breaking up with my boyfriend or girlfriend, I would say, no, no, there's not a step-by-step way of doing that. If you use an algorithm to break up with your significant other, what that will return is a slap to the face. So please don't do that. You need instead to go by rules of thumb. Like what? Maybe be gentle and kind when you're doing that. Maybe don't do it over the phone, right? Look them in the eye. Those are good rules of thumb. They won't always work the same way. That's the other thing about heuristics. Even though you do those things, you won't always get the same result. Algorithms are kind of deterministic. You know you're going to get a certain result if you do it that way, assuming your inputs are the same. But heuristics, everything is so complicated, it might not happen the same way. Same thing with a lot of pathfinding algorithms. They have heuristics built into them. So Google Maps, it doesn't check every single possible combination of roads that will lead you from A to B. It kind of just starts taking one. So it says if it's going in this general direction, choose that one. And then maybe check a few along the way, a few different options. But generally, check this one. Don't bother with all of the possible scenarios, especially if they end up wrapping you back around and pointing in the wrong direction. Just cut those out. So that's a general rule of thumb. Cut out the roads that lead in the opposite direction. You don't have to check all of them. So that's one way that heuristics are implemented in both password checking and in pathfinding algorithms, and then in other things in day-to-day life. So I need you to think about when am I going to use algorithms and when am I going to use heuristics? When am I going to combine the two?